Hi again. Here is lesson number 2 for special product and factoring when we have a plus b times a minus b, and that gives us a squared minus b squared. We're going to go the other way today. We're going to start with a squared minus b squared and go this way today. Not really much harder. I think you can do this, so let's try it. All right, so I wrote the form backwards. Yesterday or the last time you watched this, I would have had a plus b times a minus b first. Now I've got a squared minus b squared first. It's okay, they're equal to each other, so they can go on either side of the equal sign. So we're going to work the other way this time. Instead of squaring the numbers, we're going to do the opposite, which is to take the square root. So first thing I need to check is this a perfect square? T squared? Absolutely. Is 144 a perfect square? Absolutely. Is it subtraction? You bet. So since it matches our form, we can go ahead and use our little trick to solve this, to work backwards to the two binomials that were multiplied together. So to do this, instead of squaring, we are now going to take the square root of the a squared and the b squared to give us what a and b are. We're going to unsquare them. So if I take the square root, and this is my first one, this is my a, what's going to turn into my a of t squared, I would just get a t, because t times t is t squared. So my square root of t squared is just a t. So I'm going to write that in my a positions here. I had a t and a t. I want to take, don't worry about the fact that it's subtraction. Just take the square root of 144. The square root of 144 is 12. Well, that's in my b position, so I put a 12 under both b's. You cannot flip those around. T squared is my a. 144 is my b. I can't flip them. So in between them, this one gets an addition sign, and the second one gets a subtraction sign, and I'm missing my parentheses yet. And there is my final answer. Now, how do you check this? And I'm not going to check all of them for you today, but I'm going to check this one. You take the two binomials you just got, t plus 12 and t minus 12, and you FOIL or box method them to figure out what you got. So I've got t squared 12t negative 12t and 144, but it's negative. These two cancel because one's positive, one's negative. I end up with t squared minus 144. That is where I started, which means that is the right answer. The answer I'm looking for you to write today, though, is these two binomials. All right, let's try the next one. Check. Is 36m squared a perfect square? Yes. Is n squared a perfect square? Yes. Is it subtraction? Yes. Which means we can go ahead and take the square root of each of these to figure out our a and our b. All right, I'm going to take 36, the square root, and m squared. So the square root of 36 is 6. The square root of m squared is just an m. That goes in my a position. 6m and 6m. Unsquare, or take the square root of n squared, which would give me an n. And then I add my addition in parentheses, my subtraction in parentheses. The reason we can't flip this is because of this this part of the binomial. You could totally flip and write m plus 6m and not be wrong, because that's the same thing. But n minus 6m is something completely, totally different. That's why we cannot flip these positions. All right, a couple more to go. Are these perfect squares? Consider 25, 256, yes, and then q squared and t squared, yes. So we can take a square root of each of these. So let's take the square root. The square root of 25 is 5. The square root of q squared is q. So in my a position is 5q and 5q. And then my b position, the square root of 256 is 16. And the square root of t squared is just a t. So in my b position, I've got 16t and 16t. The first one gets addition, second one gets subtraction. There's your final answer. Next problem, let's see what we got. I threw in a fraction, or the book throws in a fraction for you. 4n squared is a perfect square. 1/100th is a perfect square. Now, when you look at a fraction, you need to consider the numerator and the denominator separately. Is 1 a perfect square? Yes. 1 times 1 is 1.
Is 100 a perfect square? Yes. 10 times 10 is 100. So since the numerator and the denominator are perfect squares, we can go ahead and take a square root of each of these. So let's take 4n squared first. Square root of 4 is 2. Square root of n squared is n. So in my A position, I get a 2n and a 2n. Now let's talk about the square root of 100. That is the square root of 1 over the square root of 100. The square root of 1 is 1, and the square root of 100 is 10. So my B position gets 1/10. All right, first one is addition, second one is subtraction. There are your two binomials, and again, I would encourage you, if you want to check it, you need to do FOIL and Beck's method. Two more, number 11. Ooh, a decimal. Now, think about decimals. Drop the decimal out of 1.69 first, and it's 169. 169 is a perfect square, 13 times 13. Now, when you just throw a decimal in, it does stay a perfect square. So it's going to be a decimal form of 13. We'll figure that out in a moment. Is 4 a perfect square? Yes, so we can take the square root of each of these. All right, so the square root of 169 is 13. But if we throw in the decimal, has to be 1.69, and if you use your calculator or think about the math a little bit, you're going to find out that it's 1.3. So see how they kind of go together. And I still have to take the square root of x squared, which just would give me an x. So in my A position, I have 1.3x and 1.3x. My B position, I see the square root of 4, which is 2. So in my B position, I get a 2. It's addition, subtraction, parentheses, parentheses. 1.3x plus 2 times 1.3x minus 2. Last problem. Decimals again. Drop the decimals for a minute. Is 64 a perfect square? Absolutely. It's 8 times 8. Is 81 a perfect square? Absolutely. It's 9 times 9. So we need to go ahead and find out the actual answer when it's a decimal, but it's going to be some form of 8 and some form of 9. So let's take the square root of each of these. And again, remembering this always has to be subtraction, and it is. So let's take the square root of 0. I don't know, I'm ready. Let's take that out, actually. Let's do the square root of 64, but it's which would be 8, but it's 0.64, and so the answer of that is actually 0.8. And then I've got a y squared on there, which would be y. So in my A position, I have 0.8y and 0.8y. And then in my B position, I've got 81, but it's 0.81. So if I had 81, it would have been 9. But since it's 0.81, it is 0.9. And I had a d there. Now it's d to the 4th, not squared. D to the 4th would be d squared, the square root of d to the 4th, because d squared times d squared is d to the 4th. Remember, we add those powers. So since we add them, the square root of is d squared, and so that goes second, 0.9 d squared, and 0.9 d squared. Need some parentheses, and I need an addition and a subtraction. There is your final answer. Good luck with the homework and everything that you're working on. Miss you all. Hopefully I get to see you soon. Let me know if you need any help with anything. Talk to you all soon.